Okay. Hello, everyone. My name is Esmat from JISC, and first of all, thank you for providing me with this opportunity to come and talk here. I'm going to talk about first the background about mobile technology and trend in this field, and later on, I will talk about solution we at JISC are interested for, not a spot problem indoors. Probably you have seen this photo before. Apologies for people who were in a network shop and I presented there almost same slides. This is the crowd gathered in 2005 to witness a new pop. Probably in 2005, most of the people here had mobile phone in their pockets because the penetration of mobile phone in 2005 was high at Europe. However, they were using it just for making call, which was the main service for this device. A few years later, in 2013, same place, almost same people, but there was massive difference between the way they were using mobile phones in 2005 and at this time. Now they are using mobile phones for mostly taking photos and sharing it with others. And this is not just limited to special events like this one. All these smartphones, tablets, the networks connecting them together, we are making this mobile broadband the way of our life. We are constantly either creating data by uploading them or consuming data or downloading them. And as a result, we are expecting to have very good coverage and capacity wherever we are at any time, at any place. This is good, but led us to exponential growth in mobile data traffic. As you can see, although from last 5 years, the voice, which is the yellow color there, voice traffic was almost constant, you can see significant increase in mobile data traffic. Just in 1 year, from quarter to 2014 to quarter to this year, we have seen 65% increase in mobile data traffic. And things are not going to slow down in coming years. Based on the forecast by Cisco, we will see 6.4 billion connected devices in the world in 2021, up from 3.4 billion this year. We will see massive number of connected devices. Sorry, that was a smartphone. We will see massive number of connected devices, and by connected device, I mean any physical object that can IP stack capability and can communicate two ways through network interface. That would be numbers of 28 billion. These are a number from Ericsson for quarter three this year. We will see 11%, I would say 11 times increase in mobile data traffic, and out of it, 70% of it would be video. So network not only should be capable of coping with this traffic, it should deliver the good quality of service, because this is the main requirements for video and voice. Let's see how mobile technology has evolved during these years to meet this requirement. We started in 1980 by first generation, which was analog service. It brought for us mobility. For second generation, or GSM in majority of places, we had a mass adaptation of service on the digital signal. For GSM, we had data connectivity something like 9.8 kilobit per second. You might not imagine it now, but on that time it was massive speed for the use cases that we had on that time. And step by step, we went through different generation, and now with LTE, we have up to 100 megabit per second. In some places, like in Knightsbridge in London, EE offers 150 megabit per second per user. In South Korea, getting 300 megabit per second per user is a norm in your commercial package. And hopefully by 2018, 2020, we will see the first flavor of 5G, which promises to bring us 1 to 10 gigabit per second, theoretically. As you can see, almost every 10 years, we are witnessing new mobile technology. So let's see what is LTE. LTE is one of two main technical candidates for fourth generation. Another one was WiMAX, but for the first time in mobile industry history, all players in this market, almost all of them, agreed to have one standard for 4G. Before that, for third generation or second generation, we had different standards in different parts of the world, but with LTE, we agreed on using one standard as a fourth generation. There are very few commercial deployment of WiMAX, another competitor for LTE, but they are almost 25 or 30 all over the world, so they are not that much. LTE was first introduced in 2009 in Europe, and unfortunately, although we in Europe were the first one to deploy that, the uptake wasn't great, and we are behind North America and some places like South Korea for the uptake of service. And by end of this year, we will have 420 commercial deployments of LTE. Out of that, 90 of them can provide you with 150 megabit per second. We just saw the initial deployment of one network which offers 600 megabit per second in Sydney. And these are not the only interesting things about LTE. For the first time in mobile technology history, we have purely IP-based infrastructure. Before that, in 3G, we had circuit switch for voice, packet switch for data, but with LTE, we have purely IP infrastructure. LTE also has flat architecture. That means you will have fewer number of nodes. That means we will have low latency, lower number of nodes. That means you pay less for your maintenance and total cost of ownership. And although it's IP-based, and IP we know by default is best default, LTE guarantees quality of service for us, which is essential point for providing voice over IP for our customers. So all this together, LTE brings us more capacity. When you have more capacity, you can provide more services for your users. When you can guarantee quality of service, that means you will have better user experience. And that means more profit, because you all agree that profit nowadays will not come from new users start using the service. It will come from happier customers when they change current providers and join your networks for getting service. So this is about LTE. Let's see what is 5G. The first question would be why we are talking about 5G when still we don't have 4G. 4G penetration in the UK is 25–30%, Q1 this year. In America is 40%. In South Korea, which is at least 2–3 years ahead of all the world in the mobile industry, is 65%. So why we are talking about 5G now, when we don't have 3G in lots of places? The thing is, we start deploying and developing technologies long before they make major changes in our life. And the fact that every 10 years we are witnessing new mobile technology, so it's almost the right time to talk about it. The discussion about 5G has started a few years ago, and by today, all the players agreed that 5G will bring us network society, which means accessing to information and sharing data wherever you are at any time, at any place, by anyone and anything. And this anything makes major difference between 4G and 5G. We know 5G will bring us very enhanced and high mobile broadband. We are expecting to see 1 to 10 gigabit per second. You might think what we are going to do with 10 gigabit per second. Even 1 gig is a lot for users now. But first, we cannot imagine what we are going to do with that, and later on, we cannot live without that. 5G also will bring us massive enhance in machine-to-machine communication. We will see billion connected devices connecting to the network and using service. But for doing that, there are some major issues. First of all, we need to enhance our energy consumption. We cannot carry on with the amount of energy we are consuming now. At least we need to have 90% reduction in energy that we are using. And also the cost of connectivity should bring down significantly. Another aspect that 5G promises is ultra reliability and very low latency. By ultra reliability, I mean at least 5 nines reliability. And for latency, some people are talking about 5 milliseconds between requesting the service and service coming back to you. Some people are talking about even 1 millisecond. And these are very, very bold claims. Some of them, like this 5 millisecond or 1 millisecond, requires massive changes in network infrastructure. But if you are going to provide mission-critical application, if you are going to use this for emergency system, your network should support that. So the question is, are we going to use all these characteristics for all the applications? No, each application will use just a subset of these, but 5G as the infrastructure for future should be able to provide all of it. Do we know what kind of application will be on that time? No, as we didn't know 10 years ago when we were talking about LTE, what application we are going to use today. So we will hopefully have one common physical infrastructure, and then on top of it we will have independent different virtual networks, each one serving different vertical markets. And each of them will require a subset of these requirements. So all promising things for 5G. We are expecting to see first flavor of 5G by 2018, with providing few of these requirements, but especially it will provide us the highest speed connectivity. In 2018, there are two important events. One is in Russia, World Cup, another in South Korea, Winter Olympic, I believe, and they are planning to launch the service there. And later on, 5G in its mature state will come sometimes like 2025, 2030. But we all agree that for providing these services, the major things would be coverage and capacity. You should have 100% coverage if you are going to offer these vertical market services on your network. There are some solutions for improving coverage and capacity, especially for indoors. One would be adding more spectrum. Spectrum is the blood of wireless network, but unfortunately, first, it's a limited resource. You cannot have access to spectrum as much as you want. First of all, and second of all, not all of the spectrums are the good one, or the same actually. The lower the spectrum, the better coverage. The higher the spectrum, you get more frequency out of it, but the coverage is not that much good. And it is very expensive. For just having 1 megahertz spectrum in 800 megahertz band, you have to pay something like £30 million per year to Ofcom. And this is after 30% discount Ofcom gave this year. So it's an expensive resource. It is limited resource. Even if you as the CEO of the mobile operators company agreed to pay this cost, unfortunately there is linear relationship between increasing spectrum and increasing your capacity. So you cannot address the exponential growth in data traffic that we earlier saw in the slides by just increasing spectrum. Another solution would be efficient use of spectrum, which means you send more number of bits per unit of frequency, which is good. We have done a good job in this area, but the problem is there are some limitations. When you increase number of bits that you are sending in unit of spectrum, unit of frequency, your system becomes complex. And the complex your system becomes, you are more dependent to the condition of your channel. And you cannot just increase the power to differentiate between these different samples. So there's a limitation here. And definitely we cannot address the problem just by providing complex system and an efficient model for this. And the last one in a small cell. We can deploy a small cell wherever we want, wherever we need it. And this is the topic I'm going to rest the rest of my slides talking about them. So what are small cells? Small cells are low-powered access points. The difference between access point and one of the differences between access point and small cell are they are working on licensed spectrum. That means you cannot go to eBay and just buy one of them and put there and expect to have coverage and capacity for your mobile phone. You need to buy from mobile operators. They have control on your small cell. They can turn it off if you as a small cell owner makes interference for other people. But they are easy to deploy. They are very cheap if you compare it with DAS solution, distributed antenna system. And then you can put it wherever you want. And the good thing is your users don't recognize and don't notice the difference between the service they are getting from small cells and the service they are getting from main base station. So usually we have a cell, and then we have base station, or we call it E node B in 4G at the middle, which is the mast, antenna, and the cabinet for putting this baseband controller and other devices. If you are close to the base station, you are getting good service. If you are near to the edge of the network, you are not getting good service. It's not just about distance, it's about the load on the network, the frequency they are using, the weather condition, the material they have used for the building. All of them can affect your service. So what we can do to solve the problem, wherever we don't have a good coverage and capacity, we put one of the small cells. And a small cell, I use it as a general term for picocell, femtocell, and these solutions. So major difference between picocell and femtocells. First of all, picocell is bigger than a small cell. They are usually deployed and owned by mobile operators. And they usually have dedicated backhaul to connect to the mobile operator's core network. However, small cells, femtocells, they are bought by customers. They are using customers' backhaul to internet connectivity to connect to mobile operators' core network, and they are serving fewer number of users. here you can see the comparison between different solutions that we have. In general, one question would be, which is a valid argument actually, we just said 4G is using IP, so we are going to use voice over IP in 4G. We already have Wi-Fi, we have data connectivity. Why not just using this OTT application for voice over Wi-Fi and then forget the small cell? Why we need to invest money to buy new devices and put it there? There are significant differences between Wi-Fi and small cells, and by small cell I mean LTE-based small cell. First of all, this MAC protocol that we are using in Wi-Fi, which is CSMA, is contention-based. That means you are competing with other users to get a resource. So there is no guarantee for you to have a good quality of service, which is very important for voice. But in LTE, we have guaranteed quality of service for your packet in access network. So that means your network can differentiate between your voice packet and data packet from beginning and meet these requirements, which is very important. Wi-Fi is working on unlicensed band, which means first they are competing with each other. They are competing with other devices in this band, interference from them. But LTE, small cells LTE, they are working in licensed band. That means someone has paid already for this frequency and other people cannot use it. So that means less interference in this area. And also when Wi-Fi access points are competing with each other for a frequency, small cells can talk to each other directly, which is very important because they can do load balancing, they can tune their strategic for transmission and get an optimal performance out of it. So all this together, we can guarantee quality of service in LTE while you cannot guarantee this quality of service for access network with Wi-Fi. However, small cells have their own challenges as any other solution in the world. There is a problem with interference management, resource allocation, handover between macro cell and small cells, your backhaul connectivity, because it uses a customer's backhaul connectivity and the quality of service depends on it. But luckily, the problem usually is at access network, not in the backhaul. And you always, most of the time, have over provision of resources for your backhaul. The benefit of small cells are so much that the market has found a solution for most of these challenges, and they are increasing demand in uptaking small cells. They are very easy to deploy, they are cheap, they can improve your coverage and capacity instantly. They are intelligent device, that means they can learn and sense from environment, and then they tune their configuration to get a best performance. And they are talking with each other, they have this capability to do that. And over top of it, you can provide innovative services, especially for education. These are a few examples for offering location-based services in education. These are just samples. There can be much more than that. Now let's see how we can use this solution to improve coverage and capacity for the environment like education when you have customers from different mobile operators and you cannot enforce just going and buying contract from one operator. One solution would be getting a small cell from market. The small cell available in the market, unfortunately, are single operator. That means if you have problem for EE and Vodafone coverage, you need to go, for example, from EE, buy the small cell and implement it. You can get EE's customer happier, but the problem is other users still will suffer. One solution would be duplicating infrastructure for all mobile operators independently. Even if you convince your line manager about the cost and the fact that there would be plenty of these nodes hanging around on your ceiling, the performance you are getting would be much less than that what you are expecting to get because of interference between them. So you will lose something like 60–70% of performance because of interference between different mobile operators, a small cell. So we need to look at the solution which can provide multi-operator coverage and capacity for us in single solution. One solution would be RAN sharing, radio access network. That means you have one box and this box had one board and you assign frequency for that and share this frequency between different mobile operators. There would be gateway in your backhaul somewhere, and then that gateway can differentiate between different stations and hand it over to different mobile operators. Another solution would be having a box, but there would be different independent board inside the box for each mobile operator. That means each mobile operator will have its own frequency and will have its own controller, but there would be general, I would say, management system to control the interference between these boards. At GISC, we are interested in number 3 and number 4. My favorite one is number 3. Perfect solution, efficient way of doing that, technically possible. Unfortunately, business model doesn't fly between mobile operators. There is no way of asking them to share active resources like a spectrum with each other today. They might, and I would say they have to do it in few years later, but for today, there's no chance for doing that. Who is going to put these 5, for example, megahertz frequency there, and how this guy is going to charge other mobile operators? It's a very complex business model. So we are left just with number 4, which is still good. We have found a few companies based in USA, which they just launched this product this year in Mobile World Congress. So the solution is something like this enterprise Wi-Fi. You have a node, something like that. Inside it, there are different independent boards for each mobile operators. And then you can connect it on the ceiling with that. Very simple, very easy to do. And you have a controller there, like Aruba system. And by doing that, you have one solution, one node, providing coverage and capacity for up to 4 mobile operators at the same time. So the solution we are interested, first of all, should be 4G. We are not investing on 3G because mobile operators are not investing in 3G anymore. That means solution should provide voice over IP based on VoLTE. Solution should minimally support 2 mobile operators. It should use Janet connectivity as a backhaul to connect the controller to mobile operators. It should use your LAN network to connect radio node to controller as a front haul. And it should be able to use these LAN resources between all mobile operators. That means it should be IP-based. We don't accept other protocols. And because by default there would be tunnel from your campus to mobile operators' core network, that means you can offer this service to public. So there is no need to just limit it to our students. The service can be open for public. So if you're interested, please do send me an email. We are hoping to get some good news for deployment by Q1 2016, and then have open call for pilot. So if you're interested, just contact us, please, and then we will keep you updated. I would like to take this opportunity to talk about another service, which we are in the exploratory phase in GISC to see if there is any demand for it, and then we'll go for process to implement it, to actually get it. And that is providing affordable data connectivity when you are abroad. We all agree that cellular data roaming is an expensive service. Either you have to limit your connectivity, or you will expect a massive increase in your bill when you're coming back. Solution for that would be free Wi-Fi, but unfortunately free Wi-Fi is not available everywhere. And even if it is, it's not advisable to use free Wi-Fi for the security and also for the performance reasons. So in GISC, we have started a negotiation with a company which is the biggest Wi-Fi provider in the world. And it's not because they have the massive number of access points in 120 countries, because they are partnering with different Wi-Fi providers and then gluing this together, okay? So if you get account from them, you can have access to over 50 million Wi-Fi hotspots in 100 countries. And then you can have unlimited access to this resource. You can use your EdgeRoam username and password to get the service because it supports single sign-on capability. And it is available in lots of places. Here you can see in flights, airports, flights especially in North America, airports, hotels, different hotspots. The cost for that, if you go individually to this company and buy the service for a number like 250 users, you need to pay something like £13 per month per user. If you increase your demand, something like 1,500, then you have to pay £11 per month per user. Based on our negotiation with this company, if we can gather demand or up to 20,000, and few universities, each one with minimum purchase of 2,500 join, the price will be as low as £10 per user per year. So it's a massive, massive discount here, but we need to aggregate demand here. So if you are interested, please do send me an email, and then we'll see. Yeah, you can ask questions. You can just put the hands up now, or send me an email, wherever better for you. Oh, that's great. If I have just one, the good news is, can you just write down the name somewhere? The good news is we can get cheaper price as well, because it's just initial start. So if we see demand, we can go back to them and negotiate a little harder to get more discount for you.
Yeah, the cool thing is obviously the edge of all integration with that, and the fact that the more people buy, the cheaper it is. But we were discussing over the last couple of weeks on whether or not there would be any demand, and I'm really pleased with it.
Yeah, that was very good news. If you just put your hand one more time, I can take a picture and then follow you one by one. Any question? No question? Yeah.
Hi.
Yeah.
I'm speaking from a university that's got appalling mobile phone coverage around the campus, so the kind of small cells around the campus are quite attractive. And I'm just imagining the conversation I'm about to have with my purchasing manager when she says, aren't we subsidising the mobile phone operators by providing these femto cells and backhaul? Is there an answer to that before I get asked the question?
Unfortunately, he's right, yeah.
But
she's right. But this is the model has been used for the last 5 years, and this is the interest behind it, that mobile operators are actually using this service. Yeah, we are helping them, but it seems we don't have any other choice right now. Yeah.
But I just make an observation that we've worked with a number of clients who, when renewing their mobile phone contracts, if they put coverage requirements into that specification, they can get quite significant investment from mobile operators. Granted, that's only going to be the operator that you select for your university business, which is not ideal. But it's a start.
Yeah, what we are looking is a solution that usually students can benefit from it, because that's a problem in the campuses now.
So which operators then signing up for?
We have been talking with all mobile operators for the last 1 year. The good news is, first they weren't very interested, but because of GISC intervention here and the use case we put for education, all of them have agreed to participate in this project. So hopefully we will have all of them. There are some problems here, not problems, it's the nature of this business. Because, challenges I would say, thank you. Because this is a new hardware, all mobile operators individually should test it in their lab to see if there is any interoperability issues between device and their existing equipment, and if the device can pass their KPIs. Okay? This should be done individually for each of our mobile operators. After that, we are hoping to do a friendly user trial in GISC office in Lumen House, Oxfordshire. And at the same time, we are hoping to launch open call, select 1 or 2 universities to go for pilot. And hopefully by that time, we will launch DPS for you to make it easier to buy a service and hardware associated with that. Yep.
Is there any considerations we would need to take? We're building obviously the campus at Belfast, and it has come up mobile coverage in the building, because what we found is the glass that we're now currently using is actually stopping mobile coverage in, and we've had a big problem where 2-4 buildings gone up on one of our site, and it's killed mobile coverage completely. With this building going up, I mean, the project manager run around going, what should I do? You need to do something. Is this something that will be available? When? What's the time frame?
Okay. Project, based on what we planned, has already 3 months delay, which is very, very good, considering the fact that mobile operators are part of this project. It's a very time-consuming process when you are dealing with mobile operators. I have been waiting for 2 weeks now just for assigning one meeting, one call meeting, with some people in Vodafone, because it's a complex organization, different departments don't talk to each other, and usually this kind of project needs approval from different sectors inside their organization. So 3 months is very good. I'm very happy about that. We are hoping to have these lab tests by Q1 2016. So I personally hope that by Q1 2016, end of it, we have done these lab tests. And as soon as we do these lab tests with operators, we have more control over progress of process. So hopefully by Q2 2016, you will see some good news. Yep.
Who will be designing the deployment of the appendices in the building?
There are two options. We ask for these companies to put all these different processes, RF survey, design, maintenance, as optional for your contract. So either you can go by yourself, find some company to do it for you, or that would be part of the contract you are signing with this company. So we are trying to make it very, very simple for you. Just by signing one contract, you have a full package. But ultimately, it's up to you.
That would be bought by an OG compliant.
There would be DPS there.
Okay, well, last question at the end.
We've currently got a load of O2, the small O2 boost boxes around our university. One of the problems we find with them is that they're basically black boxes. Therefore, when they stop working, you have absolutely no idea why they stopped working, and you basically get put in customer call centre hell trying to understand what's going on. Will your service, your devices have more local manageability as to be able to see what's going on with the devices? I'm not talking about kind of being able to change the kind of the RF stuff, but even some basic stuff like can it talk to the backhaul and so on.
I would assume that the solution you are using doesn't have controller, does it?
No, they're just all independent boxes, yeah.
The solution that we are looking at has controller. So it's very similar to enterprise Wi-Fi. So there's a radio node talking to the controller, and usually admin should have some high-level access to this controller. Ultimately, it is under operator's control. So this is one side of it, that the system is simpler and more flexible for admin. On the other side, we have been negotiating with this company to sort out something about these maintenance and troubleshooting. So either there would be some sort of support from mobile operators or some extra costs you need to pay for having these maintenance. We will consider it in our solution. We have been working on it.